Assalamualaikum warahmatullahi ta'ala wabarakatuh. Welcome to another video on MCTE 2311 Signal and System Analysis. In this video, I will show you the solution to sample problem on modeling of mechanical system. So for question number 1, you are given a mass spring damper system like this, and you are asked to determine the differential equation that represent this system. So if we look at this figure, we have x of t is the output, okay, which is the displacement of the mass, and f of t is input, which is the force that is pulling this mass to the right. So if we are to solve this problem, okay, the first step to do is to draw the free body diagram to represent this system. So the first step is to draw free body diagram. Okay, so here we have a mass M. Okay, and you have the displacement of the mass, which is x of t, and we also have input, which is f of t. Now the next thing to draw in this free body diagram is the reaction forces. So here we have reaction forces due to the spring, reaction force due to the damper, and also reaction force due to the mass. Okay, so if we look back at our slide, okay, so here we have the force to displacement relationship for a spring, a damper, and a mass. Okay, for the spring, the force is equal to the spring constant multiplied by displacement x of t, while for damper, the force is equals to the damping coefficient multiplied by the first derivative of displacement, which is velocity. And for mass, the force is equals to the mass multiplied by acceleration, or the second derivative of displacement. So if we are to replace this into our equation here, or our block diagram here, free body diagram, so first we have force due to spring, which is k x of t. We also have force due to damper, which is b dx t over dt. Lastly, we have force due to the mass, okay, which is m d square x2 over dt square. Okay. So after we draw the free body diagram like this, the next step is to write the differential equation. And we can do that by applying the summation of force equals to 0, okay, which is Newton's law. So here we have the reaction forces, which I wrote in green, and the input force, which I wrote in blue. So if we sum them together, okay, and let's put the reaction forces on one side, we will have m d square x of t over dt square plus b dx of t over dt plus k x of t, and let's put the input force on another side of the equation. So here we have equals to f of t. Okay. So this is the differential equation that represent this mass spring damper equation, or this mass spring damper system.